Compounding is the greatest mathematical discovery of our time. Albert Einstein. Since Einstein seemed to know a thing or two about math, let's see if we can't figure out why compounding got him all excited when we have a look at compound interest. So, just what do we mean by compound interest? Well, one definition for it might say it's interest calculated on the starting principal and the total interest. Now, what makes compound interest different than simple interest, and probably what got Einstein so excited, is this last part of the definition, and the total interest. So let's see the difference between simple interest and compound interest with an example. Let's say you were lucky enough to have $1,000 in your pocket today, and you walked into a bank that used simple interest for a savings account, and you put that money in today, and you let it sit for 1 year. So the $1,000 is called the principal. 1 year goes by and you've earned 10% interest, or in other words, you've picked up $100 on that $1,000. Now the bank will take that $100 out and mail you a check for $100. Not bad, you've earned a check for $100 after a year. And you let that original $1,000 stay in your account. And after 2 years, it's still earning 10%. So the bank is going to mail you a second check for $100 interest. Or in other words, you've earned 2 checks, or a total of $200 interest after 2 years. So 3 years goes by, and that same $1,000 principal is in your account, and you earn another check for $100 interest. So that's 3 checks, and so far you've earned yourself a nice $300. And that trend will continue with simple interest. $1,000 is the principal, which never changes, and at the end of the year, whatever interest you've earned, the bank takes out and mails it to you. And finally, after 5 years, that same $1,000 is still there, but you've earned 5 checks for interest, or a total of $500 in interest. That doesn't seem too bad. Your money started to work for you. You earned $100 per year. So with simple interest, the interest you earn each year never changes. It's always on the principal. Now let's see what's different about a bank that would use compound interest for your savings account. At the beginning, everything looks the same. You put your money, that $1,000, into the account and let it sit for a year at 10% interest, meaning it's picked up $100 in interest for you. But what's different is this time the bank isn't going to take the money and mail you a check. They're going to take the interest earned and put it back into your account. In other words, they're going to add it to your principal. So that principal by the second year will have grown by $100. So at the end of the second year, when it comes time to calculate the new interest earned, they're going to look at this number, the slightly larger principal, and they'll take 10% of that. So you've earned more interest. So after 2 years, the total interest earned will be 100 plus 110 for $210. Now again, they'll keep this interest earned, and instead of sending it to you, they'll put it back into the account. They'll add it to the principal, meaning that after 3 years, that principal has grown to $1,210. And again, when it comes time to look at the interest earned, the bank will look at this new principal and take 10% of that value. And your total interest is the sum of all of the interest earned so far, which is $331. By the 4th year, your bank account has $1,331 in it. And the interest earned that year will be $133.10, meaning the total interest so far is $464.10. Finally, by the 5th year, that principal of $1,000 has grown to $1,464.10. And in the last year, the interest earned is $146.41, bringing the total interest earned to $610.51. So take a look at the difference between the two highlighted numbers. With simple interest, we earned $100 every year, or a total of $500. But with compound interest, we reinvest the interest earned each year, and we end up with a much larger number, $610.51. So this sort of explosive growth is what really excited Einstein about compounding. And in the next few clips, we're going to do lots of examples for solving compound interest problems. And we'll need the compound interest formula to do that. So let's have a look at that formula. The compound interest formula looks like this. Let's go over what the A, P, I, and N are all about. The first variable is called A. It's the amount, and it's in dollars. It's how much money you have in your account when you're finished investing. In this example, we started off with $1,000 and we picked up an additional $610.51. So those two numbers added together are the amount, the total interest plus the principal. The next variable is P, the principal. It's also in dollars, and it's just how much money you start off with when you first start the investing. In this example, it's $1,000. The next variable is I, and it's the rate of growth, or the interest rate, usually given as a percent in word problems. In this example, our money was growing by 10% per each period. And finally, we have that exponent called N. N is the number of times the money is compounded. And if that variable seems a bit confusing to you right now, don't worry, we'll go into it in more detail in some upcoming clips. So $610.51 versus $500. Maybe this is why Einstein was all excited about compounding.